See, Charles' law says V proportional to capital T when pressure and temperature remain pressure and mass of the gas remain constant. Pressure constant and mass of the gas remain constant. In that case, volume is directly proportional to its Kelvin scale temperature. Okay. Now from this you can write V1 by V2 equal to T1 by T2. Now V1 is already given 100. You have to find out V2. Okay. T1 is given 27 degrees Celsius, means 300 Kelvin, and 327 means 600 Kelvin. So this one will be 2. So final volume of the gas will be 200 cc. That is the answer. Two molecules of a gas have speeds of 9 into 10 to the power 6 meter per second, 9 into 10 to the power 6 meter per second, and 1 into 10 to the power 6 meter per second respectively. What is the root mean square speed of these molecules? What is the root mean square speed of these molecules? 3 or 6? Power? Root 41 is there, and the power 10 to the power? 10 to the power 3 or 10 to the 6? 6 inside the root. Root 41 into 10 to the power 6 meter per second. Only 41 is inside the root. You have to only use this form, that in this case V RMS will be root over of V1 square plus V2 square by 2. If you calculate from this, it will be root 41 into 10 to the power 6. Now I will ask you one question, that suppose you have an ideal gas, then we consider for an ideal gas RMS speed. Which molecule of the, how many molecules of the ideal gas are actually moving with the RMS speed? Suppose you have 1 mole of an ideal gas, then how many molecules of this gas are moving with the RMS speed? Or can it happen that none of the molecules are moving with this RMS speed? Suppose we have an ideal gas where there are N1 molecules moving with velocity speed V1, N2 number of molecules moving with velocity V2, N3 number of molecules suppose moving with velocity V3. Okay. Then how many molecules are moving with RMS speed? Then if none of the molecules are moving with the RMS speed, then why RMS speed is so important in all calculations? In pressure calculation we write P equal to 1/3 m n RMS speed square. In all calculation RMS speed will come, and none of the molecules are moving with the RMS speed. Then why it is so important? All of you are here studying for NEET. Okay, so you read physics, chemistry, biology, all these things, and little bit of mathematics, and suddenly we are taking an exam one day on history. Like RMS speed, none of the molecules are following the RMS speed, but RMS speed is so important. So we will check your history marks and say and rank all of you that how good you are, your NEET preparation is going on based on the history marks. It is like that. If Sachin Tendulkar's cricketing ability is judged, how he sings, how he sing a song. So think about it. At the end of the class, give me the answer. Write down question number 9. The temperature of atmosphere varies with height as capital T equal to T naught minus K H, T naught minus KH. Okay, where K is a constant. K is a constant, means positive constant, and T naught is the temperature of the ground. Then find the pressure as a function of height. Find the atmospheric pressure as a function of height. Considering atmospheric pressure at sea level P naught, atmospheric pressure at sea level is P naught, comma, molecular mass capital M and acceleration due to gravity small g taken constant. G is also taken constant, means you can consider that the height is not that much such that G will vary. Option P naught bracket T naught minus KH by T naught, T naught minus KH entire divided by T naught, bracket close, to the power mg by RA, mg by RK, very large options, so it is better not to use options, better to calculate. You require two things. One is P equal to H rho g, pressure equal to H rho g, that formula, and ideal gas equation. Remaining part you have to integrate. See, This form is coming from differential element of height. It is P equal to rho GH, but I write in the differential form that if height is varying a little bit, there is a small change in pressure. For long change in height, pressure change will be appreciable, and we cannot take the throughout height pressure remain constant. So we take the differential change. So it will be normally if you integrate this one, and if with height pressure is directly proportional, then you will get the equation P equal to rho GH. That is well known equation from fluid statics or hydrostatics, you know. Now there is a minus sign. Minus sign comes from whenever from the sea level we are going up, H will increase, and as a result pressure will decrease. So that's why that minus sign comes. Okay. Now here we can write dP equal to this rho we can convert into pressure, because we know PV equal to nRT. So we can write PM by RT, that is coming as rho, where M is the molecular mass, M is the molecular mass. Okay, this density from this can be written as PM by RT. Now you can substitute this data here. Minus PM by RT into G. Now H is mentioned in the problem as a function, T is mentioned in the problem equal to T naught minus AH, KH, T naught minus KH. So substitute that in place of T. It will be dP by P equal to minus mg by R dH divided by this one is T naught minus KH. T naught minus KH. Okay, so we get this integral format. Now we have to only integrate. Limit is from P naught to P, and here it is from 0 to H. Then we can find the P as a function of H. So this integral will give you log P. dP by P means log P, upper limit P, lower limit P naught. That means log P minus log P naught, that is log of P by P naught. And this integral take minus k common, take the derivative of this part, the differential coefficient is coming, numerator is coming, so it will be logarithm. Same thing, if you take the differentiation of this term, this dH will come. So in this case we can write that is again logarithm, so log of P by P naught equal to mg by kr. This term will be log of H minus T naught by K. Okay. Now you have to put the limits 0 to H. So in the upper limit nothing will change. in the upper limit this one remains same. If you put the lower limit, this term will be 0 and you will get log of minus T naught by K. So I will write this one directly here, not writing another line, that minus log of T naught by K with a minus sign. After putting the limits, log of H minus T naught by K minus log of minus T naught by K, putting H equal to 0, you got the second limit. Then log of P by P naught equal to mg by kr log A minus log B, that is log A by B. Log A by B. A by B means H minus T naught by K minus T naught by K. Okay. Now log P by P naught equal to log this term. So I divide this term first, minus T naught by K minus T naught by K, that is 1 minus H divided by minus T naught by K, so it will be minus KH by T naught to the power mg by kr. Now you can eliminate log from both sides and it will become P equal to P naught into 1 minus KH by T naught to the power mg by kr. So with this relation, if you are going to a certain height, the pressure will change. In logarithm, after integration, the exponential logarithm term will come and those logarithmic terms will cancel because both sides containing the logarithmic term. So this is the variation of pressure with altitude in atmosphere. See, this formula you have to remember whenever the problem comes with this formula, such that you can directly put the values and find the answer. Write down question number 10. The mean free path of molecules of a gas having radius r is inversely proportional to option A r cube, option B r square, option C r, option D root r. R cube, r square, r, root r.
R square.
R square. Okay, how many missing? 1, 2, 3, 4. Where are they?
One of my friends is sick.
Sick. That boy.
The man who sit here.
Oh. Another also absent. Oh. And there, all 3 seats open. One is that girl who always feels sick. And 2 other? They are sick. Immediately they meet their parents yesterday and they feel sick. Parents are not allowed to meet. After their meeting, students feel sick. So this is coming from a direct formula. Mean free path, if you go to the mean free path formula, you will find that mean free path is inversely proportional to radius square. Okay, write down the new topic, electrostatics. The electric field due to a charge, at a distance of 3 meter, from it is 500 Newton per coulomb, The magnitude of the charge is option A 2.5 microcoulomb, option B 1 microcoulomb, option C 2 microcoulomb, option D 0.5 microcoulomb. It is option D. Just use Coulomb's law for field and you can find. D coming. Write down question number 16. The electric potential at a point P bracket xyz means the point P, its coordinate is x, y, z. Electric potential at a point P bracket x, y, z is given by capital V equal to minus x square y minus x z cube minus x square y minus x z cube plus 4. Find the electric field at that point. Means electric field vector at that point. Option A 2xy plus z cube, 2xy plus z cube inside bracket I cap plus x squared j cap plus 3x z square k cap, 3x z square k cap. This is option A. Option B 2xy I cap, 2xy I cap plus x square plus y square inside bracket j cap plus 3xz minus y square inside bracket k cap. 3xz minus y square inside bracket k cap. Option C, z cube I cap plus xyz j cap xyz j cap plus z square k cap. Option D, 2xy minus z cube inside bracket I cap 2xy minus z cube inside bracket I cap plus xy squared j cap xy squared j cap plus 3z square x k cap 3z square x k cap yz, and from that you can find the answer, that is Ex. This is equal to minus del V del x. Similarly Ey minus del V del y, and Ez minus del V del z. So you have to calculate the three components first using partial derivatives of V, and then electric field vector equal to Ex I cap plus Ey j cap plus Ez k cap. Question number 17. Which one of the following graphs represents the variation of electric field strength? Represents the variation of the electric field strength. Capital E with distance small r from the center of a uniformly charged conducting sphere, solid sphere, uniformly charged conducting solid sphere. Options are radius of the sphere is given capital R, option C, option D. C or D? Who said C? Why? Who said C? Explain. Why? Because there is this graph is given in the book. No, option D is correct. See, it is mentioned that sphere is conducting or non-conducting? Conducting. Means inside the sphere no charge can stay. All the charges will come to the surface. So inside a conducting sphere, field is always 0. And outside it varies with inverse square. So only option D is correct. First one is not correct because outside the graph, outside this sphere, the field does not vary linearly, it varies with inverse square. So straight line graph will not be possible, and C is not possible because the sphere is not non-conducting sphere. If it is non-conducting sphere, then option C is correct. But since it is conducting sphere, option D is correct. Okay. Conducting sphere means inside field will be 0 and outside field will vary with 1 by r square. Non-conducting means outside field will vary with inverse square, but inside it varies linearly. So in case of non-conducting sphere, option C is correct. In case of conducting sphere, option D is correct. So here conducting sphere is given, so D is the correct option. Okay. And this one is not a possible option because it shows that inside the field is constant. Field is constant, but its value is not 0 here. Inside the conducting sphere, it should be 0. Next question. Question number 22. What is the total flux from the surface of a cylinder of radius r and length L, radius capital R and length capital L, which is placed in a uniform electric field E parallel to the axis of the cylinder? Uniform electric field E parallel to the axis of the cylinder. Okay. What is the total flux from the surface of a cylinder of radius capital R and length capital L, which is placed in a uniform electric field capital E parallel to the axis of the cylinder? Option A, 2 pi r square capital E. Pi r square capital E. Option B, pi r square capital E. Option C, pi r pi r l plus 2 pi r square bracket, this term inside bracket, into capital E. Means inside bracket you have to write pi r l plus 2 pi r square into E. Option D, 0. One side it leaps through the other side, so net flux going in and net flux coming out are same. So in that case enclosed charge will be 0. This is coming from Gauss's law. This is the object, solid object. You can consider that this is similar, almost a cone, but distorted cone. Not exactly, the apex is not here, like this, solid object. And the charge is placed at the center of this circular face. Okay? Radius is R, length is L. You have to find out the flux passing through these surfaces, this entire surfaces. What will be the electric flux coming out of the curved surface of this object? You cannot consider exactly a cone, it's just some distorted type cone. This peculiar shaped object, what will be the flux coming out of this curved surface? I can always construct another cylinder, another this peculiar shaped object on that side, symmetric. That is the answer. So if you consider another similar object from the opposite side, then the charge is enclosed. So total flux coming out of the two curved surfaces will be Q by epsilon naught. So if you have only one side, then through that flux coming out will be Q by 2 epsilon naught. Because charge is placed here symmetrically with respect to the two surfaces. So through the two surfaces, flux coming out will be same. So from that, since it is enclosed, I consider that through the two curved surfaces, the flux coming out will be Q by epsilon naught from Gauss's theorem. And then if you are taking only one side, then it will be Q by 2 epsilon naught. So that is the answer. Question number 30. A hollow metallic sphere of radius capital R is given a charge capital Q which is distributed uniformly over the surface. The potential at the center will be option A 0, option B 1 by 4 pi epsilon naught Q square by R, option C 1 by 4 pi epsilon naught Q by R, option D 1 by 4 pi epsilon naught Q by R square. Because in a metallic sphere inside field is 0, so inside potential will be constant and the value of this potential will be the potential of the surface. So on the surface potential will be Q by 4 pi epsilon naught R. So the same potential will be at any point inside the hollow metallic sphere. Okay. So if the point is not at the center, at any other position, still the answer remains same. Question number 31. 4 electric charges plus Q, minus Q and minus Q. 4 electric charges plus Q, minus Q are placed at the corners of a square of side 2L. The electric potential at a point midway between the two positive charges. Electric potential at a point midway between the two positive charges. This is the diagram. Plus Q, minus Q, minus Q. You have to find the potential at this point. Length is given 2L. At this point you have to find the potential for this configuration. Options. Option A, 1 by 4 pi epsilon naught 2Q by L bracket 1 plus 1 by root 5. One by 4 pi epsilon naught 2Q by L 1 plus 1 by root 5. Option A. Option B is one by 4 pi epsilon naught 2Q by L into 1 minus 1 by root 5. Option C, 1 by 4 pi epsilon naught 2Q by L 1 plus root 5. Option D, 0. Potential at that point. See, this distance is L. So for this charge, potential at this point will be KQ by L. So for the first charge I write potential at that point will be KQ by L. There is one more charge here. For this one, potential at this point will have the same value. So it will be 2 kq by L. Now, for this charge at this point, this length is 2L, this is L. So this one will be root 5L. Okay. Then for this charge, potential at this point will be minus kq by root 5L. Now there is not a single charge. Another charge is there which is also at the same distance, root 5L. So again 2. So that is the total potential. So take 2 kq common by L common, 1 minus 1 by root 5. So k is 1 by 4 pi epsilon naught. Then it is 2q by L into 1 minus 1 by root 5. Okay.
What if there are charges in the midpoint of the other 3 sides?
Other 3 sides?
If it is in the
Oh. Okay. Here. Okay, fine. How? What will be the amount of that charge? Should I consider? Tell. Whatever you will tell, I will put and solve. No. You have to calculate the potential at this same point. What we have to calculate? Potential. At this point, if at this point potential I can calculate. Okay, fine. See. You want potential at this point? Okay, fine. Instead of this point, about this point. So for this charge, there is a potential. For this charge, there is a potential, but cancelled. For positive charge, there is a potential. For negative charge, equal potential, cancel. All cancels. No potential. If you calculate at potential at this point, then it will be 0. At this point, it will be 0. Only at these 2 points you will find the potential. Then you have to find out the electric field in the three regions and tell me which option is correct. They are infinite plates, infinitely charged planes carrying charge density, uniform charge density plus sigma and minus sigma. In the three regions, the electric field are given. Which one is the correct option? Positive charge, field lines are always going away from the positive charge. So in this region, for this the field lines are going along this direction. In region 2, field lines are going along this direction. In this direction, field lines are also going away from the charge. And in the region 3, for this plane, the field lines are going away from the charge. Consider this plane is absent. So with respect to this plane, these field lines are always going here, and in this direction always going in this side, because field lines from a positive charge are always going away from the charge. Okay. Now, what is their value? Sigma by 2 epsilon naught on any side of the plane, according to Gauss's theorem. Now, consider only negative charge plate is present, positive plate is removed. Now what happens? In this region, field lines going towards the plate, because negatively charged means field lines will enter into the, come to the charge. In this region it is going towards this, and in this region it is also going towards the negative plate. And the magnitudes will be same, sigma by 2 epsilon naught, sigma by 2 epsilon naught, sigma by 2 epsilon naught. No more minus sign, because I have already shown the direction. So only the magnitudes of the fields are written. Now consider both the planes are present together. You already studied principle of linear superposition, which says that field due to one charge is not affected by the field due to the other. So in the three region, all the fields for both the planes will be present with their unaltered value. Okay. Now only you have to do the vector sum. So in region 1, both fields are opposing each other, so they will cancel. In region 3, both fields are opposing each other, they will cancel. In region 2, both fields are in the same direction. So E1 will become 0, E2 will be sigma by epsilon naught, and E3 will be again 0. So only the field is present between the two charged planes. We have to first use the principle of linear superposition such that I have to find the field in the three regions for each plate separately. Then we considered that due to linear superposition, the introduction of the two plates together will not alter the field. Then use the vector sum to find the field in the respective regions. I will give one more problem. calculate the field in the 4 regions. Take your time and solve, because just now we have discussed the problem. A similar problem is discussed. Now solve this one. Try to calculate by drawing the field, by writing the field in every section separately. It is 2 sigma by 2 epsilon naught. In this region, 2 sigma by 2 epsilon naught. Similarly, in this region away from the plate, 2 sigma by 2 epsilon naught. In this region also away from this plate, 2 sigma by 2 epsilon naught. Now come to the third plate. In this region it is 2 sigma by 2 epsilon naught, but the direction is always towards the plate because it is negative charge. So in this region 2 sigma by 2 epsilon naught magnitude towards the plate. In this region also 2 sigma by 2 epsilon naught. In this region also 2 sigma by 2 epsilon naught. Now see, in this region these two will cancel each other, because this is 2 sigma by 2 epsilon naught to the left, 2 sigma by 2 epsilon naught towards right. So these two will cancel each other. So resulting field in this direction will be along this direction, and it has the magnitude sigma by 2 epsilon naught. That is E1. Okay. Now in this region, check this one, again opposing each other. Only this one is present and in that direction. Means E2 is also have the magnitude sigma by 2 epsilon naught. But direction is that. In this region, see, all the 3 fields are along the same direction. So E3, that will be equal to 2 plus 2 plus 1. That is 5 sigma by 2 epsilon naught in this direction. In this direction, again these two will cancel. This is the only field. Sigma by 2 epsilon naught along this direction. You can also put vector sign, that you can write E1 as sigma by 2 epsilon naught minus I cap. E2 equal to sigma by 2 epsilon naught plus I cap. E3 equal to 5 sigma by 2 epsilon naught plus I cap, and E4 sigma by 2 epsilon naught I cap. So only in this region the field is towards left, and all other region field is towards right. Okay. So magnitude of the field in 1, 2 and 4 are equal, that is equal to sigma by 2 epsilon naught, and in region 3 it is 5 sigma by 2 epsilon naught. Negative charge minus capital Q. It is present at the origin. Write down a negative charge capital minus capital Q. Sorry, a charge minus capital Q. A charge minus capital Q is placed at the origin. Another charge is on the x-axis at point a comma 0, means this distance is a. Another charge is on the x-axis at point a comma 0. the another charge is also given in the problem, that is plus q, plus small q, that is at a comma 0. This charge is taken to a point zero comma a. Okay, via two different paths, This is the first path, path 1, this is path 2. Okay, now which option is correct? Work done in path 1 is greater than work done in path 2. B. Work done in path 1 is less than work done in path 2. Option C. W1 equal to W2 not equal to 0. Option D. W1 equal to W2 equal to 0. Y-axis 0 comma a will be minus kq by a. So if I consider this point is say point A and this is point B, then VA equal to minus kq by a, VB is also minus kq by a. So what is potential difference? So work done equal to charge that is moving multiplied by potential difference. So it is independent of the path. Potential is the function of the endpoint, state function. It does not depend on the path followed. So at the 2 points, if potential is same, difference is 0, then work done in both the paths will be identical and they are equal to 0. So you may go through straight line path, you may go through circular path or any other curved path, but since the endpoints are equal, potential difference becomes 0 and work done will be 0. So in both the path, work done will be equal and the value will be equal to 0. If I have given that this point is different, say 0 comma a by 2 or 0 comma 2a, then this option is correct. Then VA and VB are not equal, but work done's value will be equal, but value is non-zero. So in that case, if this point is at different distance than A, then this is the option, correct option. But here it is given that this length and this length are equal, so this is the correct option. Okay. Okay. Go and in today's remaining 2 sessions, study session, study the electrostatics portion, and in the next electrostatics and current electricity portion. Then tomorrow's there will be exam. Okay, then whatever you wish you can do. Before exam, no such rule.